Personal finance practice problem using OneNote. Excel functions, present value, future value, and number of period functions. Prepare to get financially fit by practicing personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side. We're in the Practice Problems tab, down in the 1116 Excel Functions, Present Value, Future Value, and Number of Period tab. Also note, when using OneNote, look at the Immersive Reader tool. Our presentations will also be down here in the text area. Same name, same number, but with transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, got the information up top, calculations on down below. Before we get into the Excel functions, we're just going to recap what we did in a prior practice problem. You don't need to have done the prior practice problem to follow along, but we want to see how these different kind of calculations can be done to get to, in essence, the same results so that you could, one, pick the most appropriate calculation, the easiest calculation for you to do, and two, also be able to compare and contrast with other people who might be doing the same thing but using a different method. So the information up top is going to be the yearly earnings percent of an investment is going to be 12%. So in other words, we're imagining an investment that's going up on an annual basis 12% a year, and that could be an investment in stocks, it could be bonds, it could be a savings account, CD, land, a home, something like that we're imagining it's going to go up at 12%. Then asking the question, how long will it take for the investment to double? Which we could answer using the rule of 72 without even knowing what the investment is. Then we go back in and we're going to then include an investment amount, often making it more concrete, often useful, even if you have a book question that doesn't give you the investment amount and you want to figure it out depending on the method you use. You might just make up an investment number, which usually the easiest numbers to use would be like 100 or 1,000. We're going to use here 2,000 because we used 1,000 in the prior set of problems, and just to show we can use a different number, come up with the same results here with regards to the time frame. And so we're going to assume we have the 2,000 after we do the rule of 72 and see how long it takes to double, which means we want to get from 2,000 to 4,000. So we did the rule of 72, and we got to around 6. We took the 72 divided by 12 and got the around 6 years then for it to double if you have a rate of the 12%. We then looked at it last time, and we saw that we had the interest calculation in a running balance table. Very useful even if you do have the Excel functions or a financial calculator to know how and be able to work through the running balance table to see the actual compounding of the interest. Now we're going to be down here and doing the similar calculations with the present value, future value, and number of periods calculations, which are Excel functions. Now, obviously, these are Excel functions. We do this problem in Excel, but it takes a little bit more time just to format the Excel. So if you want to go into that problem and work through them in Excel and look at the worksheet, you can do so. Here we're just going to go through the concepts and see how they tie into the other calculations and see how we would do the calculations in Excel. So we're gonna look at this problem. Note, this problem isn't a problem where basically the end result is a present value or future value calculation. We're actually using basically the components of either a present value or future value calculation to back into the number of periods. So if you were to think about this, in other words, as a mathematical formula, then you could use either the present value or future value, plug in all the unknowns, and then solve for the number of periods n, rather than, or you can, rework the equation algebraically, solving for n. But note that most of the time, you're not going to be thinking algebraically of an equation for the number of periods. You're usually going to be using the future value or present value equations so that you can then plug in the unknown, use your algebra to solve for n. When we think about a function type of system as well, we can think about it similarly, meaning most people have most familiarity with present value and future value calculations, less familiarity most likely with the number of periods calculation. It's useful to know that you can still use that same algebraic concept with the future value and present value or any function if you have one unknown in the function, even though the function itself is designed to get the end result number. In other words, the future value function is designed to give you the future value at the end of the function. If there's some other unknown as a data input point in the function, then you can still kind of use the algebraic concept, but you can't rework the function itself. You can use a tool like goalseek to basically use it to get to the unknown number, or you can look for another function that basically reworks it in a similar way as you might rework an algebraic equation, but done by Excel. For example, this function being the number of periods function, and see if you can get to the answer in that format in Excel as well. So we'll show a couple different methods to do that. We're going to start with the present value calculation, and so we'll use the present value to note the unknown amount, which is the number of periods, and then we'll think about how we could use the goalseek for Excel to figure out that unknown component. So here's the argument if you were to use the present value calculation, which I'm just typing out here, not in the format of a box, a formula box basically, but just how you would typically type it into Excel. This is the most common way that you would see it in Excel if you double click on the cell or simply type it in directly. So I'm going to say equals. I'm going to put a negative up front. That's going to flip the sign from a negative to a positive number. Oftentimes that number might be more properly put in front of the future value, but oftentimes I just put the negative in front of the present value, and again, that just kind of flips the sign. If you do not have a negative somewhere in the formula, it will show up as a negative result. We're going to then pick up the rate. So the rate is something we know. It's up top. It was the 12%. Then we have the comma, and also note we're picking up the 12% from somewhere in the table. You can type in here 0.12, but it's useful to pick it up from somewhere in the table. That's why we have a cell reference here, so that you can then adjust the table, which will automatically adjust your data. So then I'm going to say tab. We've got the number of periods. So the number of periods, that's going to be the unknown. So notice this is the one that I kind of want to back into. Once again, we could do that two ways. I could look for another formula in Excel that's called NPER, which we have one up here. Use that to get the end result number in Excel, or I can say let's use goalseek to kind of figure that out. We will do both methods here, meaning we're going to use this goalseek cell right here and plug something into that cell that we don't really know what the answer is, but just to get a calculation, which we can then adjust, kind of like a manual adjustment where you can just adjust the number until we get the end result to be correct. The end result here, which we know should be, considering it's a present value calculation, it should be the 2000 basically starting point. So we'll explain that a bit more as we go. That M9 then is representing an unknown in this cell, which we're guessing. It's useful not to put 0 in there or leave it blank, but put some number in there so the calculation can be made and that you can then adjust later using Excel to do so. And then we have comma, comma, because this is a payment. Payment represents an annuity calculation. We here are looking for a present value of 1. So we're going to put 2 commas to skip that function. And then we're at the future value. The future value, if the starting point is 2000 and we want to double it, the ending point is going to be double 2000 or 4000. Note that we didn't simply type in 4000, but rather we took this cell, the 2000, multiplied it times 2 to get to the 4000. So if we plug all that in, we're going to get to our result here, and notice our result is at the 2000, which is what we needed. This is really what we're looking for, which is the number of periods, which this happens to be the correct answer here. But note, if we were to use our trial and error method and the goalseek in Excel, we would start off with something in the cell like 10 or something like that. And you can imagine then just simply changing this cell just as you would if you wanted to rework the algebraic equation over and over using 9, using 8, and so on and so forth as you get the end result closer and closer to the correct number that you know it should be. There's a tool in Excel called goalseek that basically allows Excel to do that for you. So that's one method that you can basically use one function for, solve for any of the unknowns by using goalseek to basically autofill or fill in the unknown amount without actually reworking the equation to another equation, such as in this case the NPER equation. We can also see the relationship between the present value and future value with a problem like this. Let's do the future value. We can get to the same end result. So in the future value, this future value formula is designed to get to the future value, which in this case, if we start at 2,000 and we want it to double, the future value will be 4,000. So we know the end result of this formula should be 4,000 for the end result. If we calculate this, I'm going to say negative future value. The negative sign is simply flipping the whole formula to negative. It would probably be more properly put in the present value section over here. I tend to like just putting it in front of the formula. Otherwise, you'll get a negative number if you do not have any negatives in there. Then I'm going to take the rate. So the rate in the argument, we could just type it in there at 0.12, but it's better to pick the cell up so that you can change it from your data tab. And then we have comma. We've got the number of periods. This is the unknown. This is the thing we're looking for. So like we did with the last one, we would assume here, I'm going to put it in another cell and guess what it should be. I'm not going to leave it 0 or blank because that will often result in an error in the cell in the calculation. So I'd like to put some number there like 10. And then note that I'm going to go back in there and ask Excel to change that number until the end result gets to what we know it should be, 4,000. Then we have a comma. We've got the payment that's going to be included. There is no payment. That's why we have 2 commas here, because the payment indicates a calculation related to an annuity. This not being an annuity, therefore we're going to have 2 commas to skip that argument. And then we've got the present value. The present value is the starting point. And we're imagining the starting point to be 2,000, the ending point being 4,000. So if we were to enter this in, we get the 4,000 because we currently have the proper years, which is the 6.12 here. But we can imagine the same scenario if this was at something other than 6.21, like 10. We can imagine just being able to get down to the correct number by typing 9, typing 8, and so on. Trial and error method to get this number close to what we think it should be, 4,000. We can get it, in essence, exactly what it should be by asking Excel to do that, which Excel can do quite easily using the goal seek feature, which we do in the Excel practice problem, if you want to check that out. Now, the other method, of course, is to say, hey, look, this NPER is the one that we need to be figuring out. I can't rework Excel's function myself like an algebraic equation. I can't do that. I can back into it using goal seek, but Excel might have done it for us and have another function, in this case with the name of NPER. So this abbreviation, number of periods, useful to note if that's the unknown, because that's often what Excel will call the other function if they have another function solving for that unknown component, which of course they do here. So we can do it that way. We could say this would be the most direct way to do this because we're solving directly here for the number of periods, which is going to be that 6.12 again. That would be equal to the NPER brackets. The rate would be the 12%, which we could type in there, but it's better to reference the cell reference. Then we have comma, comma, because there is no payment, because we're not referring to an annuity here, but present value or future value of 1. And then we've got comma, the present value. That's going to be the starting point, which would be this 2,000, which we're not going to type in there, but refer to the cell here. Also note that I have a negative on that 2,000. That same kind of negative issue comes into play with these present value and future value calculations. If you do not put any negative in this calculation, you'll get an error message. It won't even give you a negative number. So you have to put the negative in, and then that kind of forces you to put it in where they kind of want you to put it in, which is on this present value. So you got to make sure to do that. If you don't do that, then just remember you probably get an error message, and you got to go back in there and try to add a negative sign where you think it should go, and it should then calculate. This is also why these kind of quirks with these formulas that you may not be as familiar with is another reason it's quite useful to know how to back into it with the goal seek, so you can get an understanding of it, which most people can do better with a function that they know, and then see what the quirks are, what the weird things are if you use a function that you're not as familiar with. And then we're going to say comma, and then the future value is going to be the ending point, which would be if we start at 2,000 and double it, it would be 4,000. You could type in 4,000, but again, we'd rather get that from the formula, taking the 2,000 up top, which is in cell B7, multiplying it times 2. That gets us directly to then the 6.12. Now note, that should give us an idea that these formulas obviously are related to each other, but notice no matter which way we do this, we still kind of get this magic number at the end, which is great. But look how much more detail we also get if we hit the running balance calculation. We get to see how this interest is actually accumulating upwards from a year-to-year basis. So no matter what kind of present value, future value kind of calculations we are using, it's often quite helpful, no matter basically what we're doing, to do a running balance kind of table in conjunction with it. Even a long one is usually fairly easy to do if you do it in Excel, because it gives you that better feel and understanding of what is actually happening.